Thank you so much for joining the Introduction to GraphQL workshop. My name is Shannon, and a little bit about me. I'm a front-end software engineer at a startup called Pace, and outside of work, I am working on tech skills workshops with a few of my friends. So we do these types of workshops here and there. You can also find me on Twitter or LinkedIn if you'd like. But yeah, really excited to walk through some of the GraphQL technology. And this is something that I use on the day-to-day, so it's definitely very relevant in the front-end software field right now. So a few things that we will be exploring today is going through the basics of what is GraphQL, what are some of the benefits of GraphQL, and we will also be building out our own GraphQL server, and we will learn about querying that server too. Okay, so the big question here we have is, what is GraphQL? As you can see from the example on the right side, GraphQL sits in between your clients and your data sources. So this could be APIs, it could be databases, webhooks, and you can have clients coming from many different locations: mobile, web, tablet, and GraphQL sits in between those two and will return the data that you need. So it is a query language for APIs, meaning we can structure our query to define what data that we want back. And it is also a runtime for fulfilling those queries. So the runtime will be able to parse what the request coming in looks like and return the relevant data back. So we have the benefits of GraphQL is that you get back only the data that you want, and you can also structure your objects to create relationships between them. And it's a centralized location for getting all your data. So if you have to make requests to a few different third-party APIs, it comes all into this one centralized spot. So you might get a request from a project manager or whoever, and they ask you, I want to show my favorite artists and top songs. Can you help me out? This is a critical mission right now. We need to figure out a way to do it. So my first initial thought, I might think, oh, maybe I can start with a REST API. How would this look like? You might have to make requests to multiple different endpoints. You might be familiar with the structure of these REST APIs. If I want to be able to display a song and title and the time, I'll have to make a request first to the artist, get the ID from that artist, then I have to make a request to the album with that album ID to get the song ID, and from the song ID, we can finally get the title and the time. So from the front end perspective, this is quite a long process, and it's quite a slow, complicated process. And we only maybe want one or two of these data points, but we have to make requests to all three. So is there a way that we could do this all in one location? Well, let's take a look at what this would look like in GraphQL. So I have a GraphQL instance running, and I will just show you how this will look in our playground, and we will be building this out as we go. So starting off, I want to make a query to get back a list of artists. And you can see already as I start typing, I'm getting suggestions for what types of queries are available. And on the left side here, I also have documentation that I can expand upon and even click on to check or uncheck those fields. So I can see that I have access to this query artist, and within that type, I have access to the ID and name. So I am going to just write this out. We want to get back all the artists. We want to get back the ID and name of them to start. We can click run to see an example of the result that would come back from this. So I've created a database with a few different artists here. You can maybe tell some of these artists I am a fan of, so hopefully this can be relatable for some of you, but you can also put in your own data or fetch from a larger data set. You can see I've specified ID and name, and I've gotten those values back. If I actually didn't want the name, I just wanted the ID, I can remove it directly from the query, and the results will dynamically change. So with REST APIs, you are always getting back the same set of data, and you don't actually have control of what data you get back. It's always going to be a large amount of data that you might not need. All right, so going back, we've seen an example of what this query looks like, and now we're going to build out the server ourselves. So let's take a look at some of the code. I'm just going to close this down so we can see. So we can see an example of the code itself as well. So the schema is a collection of object types. This is going to define what the client can and can't do. And the benefit of this is that it hides some implementation details. So we don't always need all of the fields to be returned. We might only want to expose a small subset of those to the client. The first thing that we need to do is we need to create an artist type. What that looks like is we use this keyword type, artist, we have the curly brackets, and we define a field and the type of that field. So GraphQL comes with some built-in scalar types. Some of these are ID, int for integer, float is a decimal floating point number, and string you might already be familiar with is text, and Boolean, we have the true or false. So in this artist example, we will set the ID to the built-in GraphQL type ID, name to string, and albums is going to be our own type album that we define. Here we also, you might notice this exclamation point. This will say that the ID cannot come back as null. And the square brackets define that the albums coming back will be a list of albums. We also will have to define the query itself. This is what we were typing into the GraphQL playground. And this defines the entry point into the schema and what that query returns. With this, we can also pass through variables such as ID and get back one particular artist. All right, let's go ahead and add this into our code. So I've created this initial boilerplate. We are going to be using Apollo server. I'll just make this a little bit bigger. Hopefully this size is okay. Let me know in the chat if anything needs to be updated. Maybe I'll make it one bigger. All right, so Apollo server is a server that will set up some of the initial boilerplate of GraphQL for it. This will allow us here to, in type defs, we define the GraphQL type definitions. So we're going to start off with defining a type of artist. Oops, I can't type. And in here, the artist has an ID. This cannot be null. And they also have a name, and this will be a string. And they have a list of albums. So we could put all of our data that we want all in here, but we want to make it sure that it makes sense from a business perspective as well. And from the business logic perspective, it would be nice for us to also have a type album. Here, the album will have as well an ID. the album has a title that is a string. And it also is going to have some additional information like the genre of the song and a list of songs that the album will return. Let's start off with just the title and the genre. So this album is going to be returned as part of the albums from artists. And the album itself cannot be null, and the list being returned, we don't want it to be null, so we add these exclamation points. The type defs now are passed in to our Apollo server here. So GraphQL is aware of what types that we have access to. And then we also want to define a type query. Here we will have the query of artists that will give us back a list of artist types. All right, let's go back to the slides. Okay, so we've just added in our query here that we've specified artists. We've also added in our type artists. The next thing that we need to do is say, when this artist query gets called, what happens? So we have what's called a resolver, and the resolver will define where the data comes from, if it comes from an API, a database, and the function name has to match the query type that we've defined earlier. So in this case, we will use this query syntax and specify the function below. This will go into our resolvers. So we have query, and within query, we have artist. This also takes in a few different parameters. We have the parent, which we won't be using yet, but will be passed through from any parent of the query, the arguments that we will pass through, the context which we will set our API in, and additional info about the query that we won't yet need. So with the convention, we will use underscore if we are not yet using it. So we had parent, which we don't need access to. We had args. Args we also don't yet need access to because we are returning a list of all artists. Then we have the context, which we will want. This is where we pass through our API. And last but not least, we had info, which we won't need, but since it's the last parameter, we don't have to define it there. Okay, so the next step is, so far our data sources is empty. We need to be able to query an API or a database of some sort to set the data source here. So I've created just this boilerplate music API that pulls in from Apollo data source REST. This will give us some out-of-the-box functionality. So I will start by setting the constructor and calling super to set any parent values. And then I will set the base URL of this. And I'm just running a sample API locally. So we will use localhost 3000 here. Now that we have set the base URL, we have to also set a function that can call the API to get us the list of artists. So we will call this getArtist. And within getArtist, we will return the API here, .get, and we will specify artists. Okay, I think that should be good. Going back, we now have our data source initialized, but we need to return the API itself. So we are going to be creating this music API and setting it to a new instance of the music API that we've just created. And so when we get our artist, we return, we will need the context here, and we will get context, will return back data sources. And on the data sources, we get this music API below. And on here, we will call it get artists. Okay, so there may still be a couple of fixes that we have to do along the way, but we have set up our types, our query, a resolver for that query, and where that data source is coming from. So if we go back to our sandbox, I will just actually start our servers because we're first running, we were previously running one that already existed. I will start our server, and then also start our database, which npm run database, this should be able to start. Sorry, some technical difficulties here. Oh, I haven't actually gone into the initial folder, that's why. So now we have our REST API running on localhost 3000, and we have our playground running on localhost 4000. So when we refresh this, actually, I'll just go directly to localhost. We get this landing page that comes with Apollo directly. And when we get to this page, we can see we have a query of artist and ID. So let's see. The issue that we're having is get artist is not a function. This is likely just a typo here. Get artist. And then we should be able to see this get artist in there as well. All right, perfect. So we're getting back a list of all of our IDs. And when we query names, we are getting back that result as well. Perfect. Everything is up and running for artists. So the next thing that we need to do now is artist has no knowledge of albums. So if I query albums here and I try to get the ID, we won't yet know how to return the result of this album. So what GraphQL allows us to do is to add a resolver for a specific object type. that means if this doesn't get called, the query will run just returning the ID and name that it has access to so far. But if we specify the album resolver, we can also get back the albums in that same initial query. This will reduce fetching for only when we request this albums page. All right, let's add this resolver here. So we have a resolver for artists, and we are going to add another resolver here for the type of when artists gets called. And we want to access the albums that it has access to. So similarly, we have those 4 arguments again, but this time we do want the parent. We won't need, actually we will need the arguments this time because that is going to be the album IDs. And then we also need the context again to be able to query our data source. So if we just, let's try console logging the parent, just so that we can see what result comes back now when we run this query with albums inside. So as usual, we get an error, but you can see that we are now logging the results of the parent. And what we want to query for are these album IDs. So what we're going to do is we will create a new endpoint in our music API to get albums, similarly to get artists, but we are going to get one specific album. So this will take in the album ID, and it will return a get request to albums with the following ID, and we will be making this a template literal so we can pass that ID right in there. Now we want to iterate through these album IDs. We will map through them. And for each album ID, we will return a request context.data sources and pass through the ID that we are looping over. Perfect. And just in case the parent does not have a list of album IDs set yet, we are going to just return an empty array. This is so that it doesn't get stuck at this point and we still return some result. All right, so now the artist has knowledge of the album. Let's take a look and see if this all works as expected. All right, so there's no knowledge. We're getting back the empty ID. I think this is because in our parent, again, this is meant to be plural. It seems like that's the tricky mistake these days. Okay, so here we have another error. Let's debug through this together. Oh, we need to specify from the data source that because we could have multiple APIs, we need to specify that it is going to be the music API. Let's try this one more time. Great. We are now getting back the albums IDs associated to the artist. And if I want to query also some additional information about the album, I can see what access I have to that. So I think genre was one that we added. And you can see we've got the different album genres, and we might also want to see the title as well. Perfect. And this is all happening in one query rather than having to make multiple different queries as we would with REST APIs. Okay, the next step that we need to do is be able to create write operations. And this is what we call a mutation type. So we can use the keyword mutation here, and similarly to query, we define what the client has access to write. In this case, we want to be able to add an artist with the name where we input the name, and the result coming back is the artist itself. Do we have any questions so far? I'm just going to take a quick look at the chat. Okay, so far no questions. Let me know if I can clarify anything along the way. I'll try to pause every once in a while to take a look. All right, getting back to this. All right, so we have our query, our artist query, and we want to add a new type within the resolver called mutation. And I'm just mapping out that I'm in the right spot for this. The mutation will take in, this is the mutation resolver, and we want to call the mutation resolver add artist. Once again, we have the same parameters that we can pass through. We don't need access to the parent. We will need access to the args and the context as usual. And here we didn't actually use args, so I can put underscore in there. And in order to match this same mutation, we have to add the type for it up here as well. So we are going to specify type mutation. And this will have a mutation called add artist that will take in the ID, or actually just the name, which is a string. And the ID will be automatically generated here. And this will return the newly created artists. And these types refer to the same types that we've defined above. So now we have defined the type, and we have our matching resolver defined here. So what should happen when we add an artist with a name? We want to create a new artist in our data sources through the music API. So we can do the same call here, although here we want to have create artist, and we want to pass through the name, and that is going to be coming from args. If we also want to shorthand writing args.name here, we can actually destructure the name directly in the parameters, and then we will no longer need that. This can be also the same for context. So if I know that I need data sources from my context, I can just write data sources here, and then I can remove this. Cleans up our code a little bit. So we're going to call create artists passing through our name. And since these are the same, we can shorthand it as so. But this function doesn't yet exist in our music API. So we are going to go ahead and add it in here. We are going to create a single artist. And this will take in the artist object, which in this case, we've just passed through the name. And we will return a post to our artist with a body here. So you can also see with Visual Studio Code, it will define what the parameters are. So the second parameter is a body. This is also useful if you ever are unsure at any stage. For example, like when you're adding what does Apollo parameters take in, we can also see it through there, for example. So I'm going to pass through the artist's name here. So we are creating a single artist, passing through the name, and this will post to our localhost API with the body of name. So let's go ahead and give that a go. I'm going to just create a new tab here, and I'm going to say this is a mutation. Let's call it add artists. And this mutation will call the add artists. We've specified we want to see the results of the name and ID coming back. And the add artist will take in a parameter of name. And here I'm going to add a name of another artist that I like. So let's choose Olivia Rodrigo. Some good new music coming out. Let's see how it goes. All right, so we have another error. This is definitely a debugging process. Let's see what we have now. 404 not found, music API. I may have named them slightly differently. Create artists. Should be saved. Oh, again, the REST APIs are plural for the endpoints, and then even though this is a singular function, the standard of the REST APIs are plural here, so that should likely be the issue. Perfect. So we've added the artist successfully. If I go back now and query my artists that I have available, I can see the one that I've just created is now visible in the query. I see one of the questions we have is, can we also use TypeScript with GraphQL types? So we can use TypeScript as a language in order to create GraphQL APIs, but we will still need to always define our own types, our own GraphQL types. So even though we would use TypeScript, we would still need to define these types above. However, for example, if you were wanting to be more concrete about the results of these functions, you could specify a Typescript type here. Hopefully that helps answer your question. And the question was, can we also use Typescript with GraphQL types? Just to clarify for any viewers. Perfect. So we've been able to add our resolver, and this shows where we save our newly created resource, and it creates the artist with the same name argument that we've passed through here. We've already gone ahead and added the mutation. So the last thing that we are missing is we've been able to get the artist, the albums of that artist, but we haven't yet been able to get access to the songs. So if I type in song here, remember our initial feature request was we want to be able to show the song title with some information about the time of a song or top favorite songs. So if I query title here, GraphQL doesn't know what this field song is. And these error messages are actually pretty useful for us to read. It kind of defines what is going wrong. So cannot query field song on type album. So we know we need to go back to our definitions, and we want to add a type for song. Song will take in an ID, title, which will be a string. We will also have the song length, which we call time. This will be a string for now. And I think we also had some additional information in our database that we might want to reveal to the client. So I'm just going to take a look at what type of information I have access to in my database. I can see in the song I have access to ID, title, time. In albums, we also have access to release date. So if we want to reveal that to the client, all we would do is go back to our definition, and we would say we want to show the release date, which would be a string. And there might be the case where the release date is not yet always defined. So maybe we don't want to make it non-nullable. Someone might announce an album, but they don't yet say when the release date is. So we want to make it flexible enough to handle those cases. And an album will also have multiple songs. So again, we will have song IDs. And the result of this will be a list, which we use the brackets for. And inside, we specify we would return a song object. And the list also cannot be empty. So even though album can see that there is a type of song IDs, we still aren't resolving this song anywhere yet. We need to create a resolver for it. So once again, very similarly to artists, we are going to say when the type, just make sure that I'm in the right bracket here. So we want it to be outside of the artist as it's its own resolver. We will say when we get an album type and we are querying for a song, here we want to have the same arguments as above. We need access to the parent once again, which will be the song IDs coming from album. We don't need access to the arguments, and we will need access to the context. I will use the shorthand that we've been using here. And within songs, we want to return. Very similarly to this, actually, if I wanted to, I could even just copy this over and say the parent, we're passing through actually the song IDs here. We want to loop through these song IDs. Another shorthand that we've mentioned, I can actually just specify the song IDs destructured, and then I will not need to say parent in front. So we will map through the song IDs, and for each song ID, we will go to the data sources and we will get the song itself and pass through the song ID there. This get song, as you can see from the terminal, is defined in the resolvers, but not in the schema. So that tells us to go up. We've got our artist query, and then we also want to add one for the albums, although this will just be songs. Just working through this just to make sure that I'm not missing anything. So if we query a specific album, we can take in the ID, and we want to return the album itself. Here, this will allow us to query album through here. We will also want to add one for song. Let's first go back to get song. We need to specify the get song in our data sources. So we go into our data sources again. We want to get a list of the songs, or get the song given its ID, very similarly to this get album. And we will return this .get and pass through song with the following ID. So here we've specified song IDs, but we just want a list of all the song objects, and the ID is getting passed through from the data source. All right. So if we go back here, we should be able to run this songs. As you can see, the error message is also quite useful for us here. We can now request a list of songs. We can get back the title. We can also get back the other information that we wanted, such as the time. On here, we can see that coming back now. We can get back the album release date if we like. We can get that coming back now. So our initial request of showing our favorite songs can now be fulfilled with one query rather than 3 or 4 different queries. If we also want to expose querying a single ID from the client, we can specify it here as we did. We want to be able for the client to request a single album ID and get back the result. So in this case, I'm going to add another Resolver under query for album. This will return a similar thing, but instead of get artist, we are getting a specific album. And this will take in, we can also create it so that we are getting all albums first to start. I'll just start with that so that we have a similar setup, and then we'll do the second one, which is getting a single album. So in our music API, similarly, we could do a get albums, plural, and this would just return a list of all the albums that we have access to. I've got to make sure I get my spelling right. So if we want to have another query where we just get the albums back now, we can do that without having to first get the artists. And we can still, because of how we've structured our objects, we can still get the song back. So this kind of shows the flexibility that GraphQL comes with. So some of the topics that we've explored today as we come to an end, we've talked about what is GraphQL, the benefits of GraphQL compared to other typical APIs, and we've built out our complete GraphQL server ourselves, and we've been able to query the results of that server. So that is pretty much all that I have for you. Thank you so much for joining. Some additional resources I found is Odyssey Apollo GraphQL has been really helpful. They have free tutorials. Also, this is Egghead.io is another really good one, although it is a paid membership, but that's more if you want to explore other front-end topics. I will leave a link to the GitHub repo that I've been demoing today in case you want to take a look at the final and initial implementation and give the go of making your own GraphQL server. And if you have any questions, I'll stick around. We've got about 9 minutes until the end of the session, so I'll answer any questions you have along the way or clarify any topic points that we've covered. Thank you, everyone, for joining.